Hey everyone, thanks for joining. So, on a really sad day, June 30th, 2025, something truly devastating happened in Telangana, India. A massive explosion ripped through a chemical factory called Sigachi Industries. The blast was so incredibly powerful, people heard it miles away, and a whole multi-story building just turned into a pile of rubble in seconds. The human cost here is just heartbreaking. We're talking about 36 lives tragically lost, with so many more injured and families desperately waiting for news about their loved ones. It's a terrible situation. But beyond all that immediate pain, there's a big question we need to answer. What was the science that made this blast so destructive? What really went on? So, this factory made something called microcrystalline cellulose, or just MCC. Now, don't let the big name fool you. MCC isn't some super dangerous, exotic chemical. It's actually a pretty common and safe ingredient, used a lot in the pharmaceutical world. Think of it as a binder, like the stuff that holds your medicine tablets together. It's completely fine when it's in your pills, but the danger creeps in during the manufacturing process. To get MCC ready for medicines, it has to be ground down really, really fine. And right there, that's where the science gets super important. Imagine a big log of wood. It burns slowly, right? Now, think about superfine sawdust. If you throw that into the air, it can explode. Why? It all comes down to something called surface area. For a blast like this, what we call a dust explosion, to happen, you need 5 specific things to line up perfectly. We actually call it the Dust Explosion Pentagon, because each of these 5 points is absolutely critical. First, combustible dust. And yeah, we definitely had that, in the form of that superfine MCC powder. Next, dispersion. The dust can't just be sitting there. It needs to be floating around in the air, creating a thick, cloud-like mix. Then, an oxidant. That's usually just the oxygen that's all around us in the ambient air. Crucially, an ignition source. Something, anything, that gets hot enough or sparks to set off that dust cloud. And finally, confinement. The explosion needs to happen in an enclosed space, like a machine or a building, so the pressure can build up super fast and really amplify the blast. The biggest takeaway here is that idea of surface area. When MCC is meticulously ground into these minute particles, its collective surface area expands drastically. Picture taking a single large sugar cube and crushing it into thousands of tiny grains. Suddenly, way more of that sugar is exposed to the air, ready to react. This means that far more of the material is directly exposed to oxygen simultaneously, allowing a chemical reaction, rapid combustion, to happen almost instantaneously, rather than a slow burn. Now, initial investigations into this Telangana disaster are pointing to a crucial piece of industrial equipment, a spray dryer. This highly specialized machine is designed to convert liquid MCC slurries into fine powder by spraying them into a chamber filled with hot air. In a tragic twist of irony, this very process, by its nature, creates the perfect storm for a dust explosion. The spray dryer effectively fulfills 2 critical requirements of our Dust Explosion Pentagon. It constantly produces vast quantities of finely dispersed MCC dust, and it does so within a naturally confined environment. The dryer malfunction is strongly suspected to have provided the all-important ignition source. This malfunction could have manifested in several ways. Perhaps through the accidental self-heating of accumulated dust inside the dryer, or a failure in the temperature regulation systems leading to an uncontrolled rise in heat. Alternatively, mechanical friction from rotating parts within the dryer could have generated sparks or hot spots. The constant movement of dry powder can also generate significant static electricity, which, when discharged as a spark, could easily ignite the dust cloud. Once these 5 dangerous conditions converge, the explosion unfolds in a terrifying, cascading chain reaction. First, a primary explosion occurs within the confines of the spray dryer itself. The incredibly rapid burning of the contained dust cloud generates an immense and sudden increase in pressure. This pressure wave isn't just destructive on its own. It acts as a powerful catalyst for the much larger catastrophe. This initial pressure wave blasts outwards, instantly dislodging and stirring up any settled dust layers from every available surface within the factory, ledges, beams, floors, machinery. This massive disturbance creates a new, far larger, and significantly denser dust cloud that saturates the entire building's atmosphere. Crucially, the intense flames from the primary explosion then act as the ignition source for this widespread, building-spanning dust cloud. This triggers the secondary explosion, an event of terrifying scale and power, far more devastating than the initial blast. It's this secondary explosion that typically causes the catastrophic structural collapse and ignites the widespread, raging fires we witnessed in Telangana. The Sigachi Industries blast stands as a stark and profoundly tragic reminder of the immense, latent power hidden within seemingly innocuous materials when conditions align precariously. It underscores, with undeniable force, the critical and ongoing importance of implementing and rigorously adhering to stringent safety protocols in all industries that handle fine combustible powders. This includes meticulous and regular cleaning routines, robust maintenance schedules for all machinery, and advanced explosion prevention and mitigation measures. As comprehensive investigations continue and the arduous work of relief and recovery proceeds, this devastating incident serves as a powerful and urgent call to action. It's a global imperative for heightened industrial safety across India and, indeed, worldwide, with a solemn goal of ensuring that such an preventable human and environmental catastrophe is never, ever repeated.